Yeah, first of all, thanks for joining the talk. My name is Arturo Perez. I'm a software engineer at Embark Studios. Um, Embark Studios is a company based in Sweden, in Stockholm, and we are currently developing two games using Unreal Engine. And today we're going to talk about maintaining build stability in Unreal Engine. A little bit more about the games. One of them is called Arc Raiders. It's a multiplayer third-person shooter where you play in a devastated world. And the other one is The Finals. The Finals is a first-person shooter where you play in big arenas with a lot of environment destruction. And both games are meant to be games as a live services. So this means that we are gonna constantly releasing new content, and this is basically gonna define our verification strategy. The other thing that is important for us is that both teams at the company are developing the two games using the same version of the Unreal Engine, also same plugins, and they are evolving the same shared code base. So that's going to reflect a lot on the workflows that we are setting. So we're going to go over to those two things today. When we talk about verification, there's usually two strategies that you can follow. One of them is that you can allow the submit to happen, and then you verify, and that's what we call post-submit verification. Or you can try to verify first, only allow the submit to go in case verification is successful. And we are calling that press submit verification. For our case and for the nature of our games, we believe that press submit verification is the way to go for us. We don't see doing it any other way. And then the question becomes, can we do this fast enough? So we don't block developers too much. Let's define first what we mean by verification, because this is something that can mean different things for different people. So for us, verifications means all the steps that we need to do in order to create a proper version of the game. And in Unreal, this means, yeah, we'll compile the editor, cook the content, compile client, compile the server, compile blueprints, execute all the asset validations that we are writing, run the tests in client, run the test for server, boot the editor with cookie and your script, and ensure that the server is able to boot. Of course, if you pay attention to that, we could split those steps into two parts, because what you do in client is something that you can do in one part, and what you do in server is something you could do in another machine. So this is one of the strategies that we are going to follow in order to have a fast pre-submit verification. And the other strategy that we are going to follow is that we are going to detect special steps that maybe are not required in case we do a pre-submit verification. I'm curious right now about how many of you, with this context, do post-submit verification. Okay, quite a lot. And how many of you do pre-submit verification? Okay, almost the same amount. Of course, I saw you, and some of them are doing both things, and that's a clever decision. So we're going to follow one case study to show how this evolved. In our case, we're going to focus only on the client part. We're going to forget now about client for a while. And yeah, following the two main principles that we have been mentioning. If we look at the first version, that was the original post-submit that we had a long time ago. Yeah, one of the rules was saying, hey, if there's something we don't need to do, we can remove it. So in our post-submit verification, we were actually creating the binary and submitting it somewhere. But in pre-verification, we don't need to sync the binary. So these kind of steps can be removed doing just that, we went down from 50 minutes to 45. Pay attention to that asterisk, because that means that those times are a lie. But I want to go over that a little bit later. Let's wait 2 slides or so. In our second step, we said, okay, yeah, but we don't need cooking to run the test. So can we do this in 2 different machines so we can execute things in parallel and we can remove the cooking times from one of them? Doing that, we started executing things in one agent. So we are compiling editor cooking and compiling client in one part and doing the rest on the other. But then the problem is that now that asterisk is not an asterisk. Even if we went down to a minimum time of 25 minutes, the asterisk is showing that sometimes we have really big times. And this is because compile times are unpredictable. I mean, depends on what you modify. If you modify an important header, then you are triggering a lot of recompilation and you are on your higher times. At the same time, once we're using agents, the intermediate state, the incremental build things, are also an unknown thing. I mean, your build is going to depend on what that agent did before. If it did something closer to your changes, it's going to be faster. But if the agent was not working for a while, it's going to take a lot. So how can we go further? We started looking at our data to see how to improve this part. And we saw 2 interesting things for us. One is that we started to paying attention to how many modifications we had per day and which type of change we were dealing with. And we saw that most of the time we were doing content modifications. So this is one important thing. And the other was disk space. The changes that are modifying the engine are taking much space than the changes that are done only for content. The reason for this is, well, of course, the different configurations where you are building. You are building with the development, testing, shipping, and that space is growing. And why is that important for us? Because you can say, oh, disk space. Why is disk space important? Well, for us, it is important because we have a virtualized build farm that in the end works over a bunch of on-prem machines. And if we can create the small machines, means that we can have more virtual agents to perform more tasks. So this helped us in 2 ways. One is we started to have more than one agent type, and we started to calling them light agents to the agents that are going to perform content validation, and heavy agents, and these are the agents that we are using to perform engine validation. So with those numbers, we also decided to have more verification pipelines. So we started to have one verification pipeline that is in charge of the content verification and specific verification pipelines that are in charge of the engine verification. Okay, so the first thing that happened is that for content verification, we don't need to compile the editor. And also, we don't need to compile the client. At the same time, we could parallelize more things. So now we started doing things with 3 agents. Why we don't need to download why we don't need to compile and where to download the editor from? Because we still have post-submit pipelines. So the editor comes from our submit pipelines. Doing that, we could bring our times down to 20 minutes. And that was pretty low, but we wanted to go even further. And the question is, can we do that? Could we do it? The answer is yes, but with a catch. What is taking the most of that time is the cook part. And we could not split cook between different agents. And And the only thing that we thought we could do was use iterative cooking. Epic is warning us, well, not us, everyone, not to use iterative cooking because it's not reliable when you want to create binaries. But we started to think, okay, but we are not creating a binary. As we are not creating a binary, and the post-submit pipelines still use cook without iterative cooking, I mean, it's a normal cooking, we could be able to trust the binary that we will generate later, but at the same time here, we can get the speed of iterative cooking. It's true that doing iterative cooking, we're gonna miss some cases. It's not perfect, so it could be that this verification say, hey, everything is okay, but then it's not true. As we still have the post-submit pipelines there, we said, okay, maybe this makes sense, let's start trying it. We did not saw a lot of failures related with that, and maybe the only two that I remember were cuts later on the post-submit verification pipeline, so we decided to leave it. There's a mistake right now in this slide, and it's that I'm using the term incremental cook. This was something that was natural for us because it's the same way that you call incremental build. Why not call this thing incremental cook? But yesterday in Mark Lintott talk, they presented that they are working on something that they actually want to call incremental cook, and it's a reliable version of the iterative cooking. So this is not a slide that comes from the future. This is a mistake. That also means that we will be able to go down those 10 minutes. If you did not saw the talk yesterday, I recommend that you watch it. There are more things coming about cooking. One of them that he mentioned is that it's going to be multi-process cooking, and the other is that at some point it will be possible to cook using more than one machine. But that's something that is for the future. Yeah, what happens then? Oh, well, there's one extra point. What happens if our tests at some point start to last more than the cooking part? Well, that's something that is not a problem for us because we can split the test in batches and we can add an extra agent to parallelize more, and we will be able to split tests during more machines. But that's something we cannot do with Cook right now. So that's why I think what was announced yesterday was really nice. And what happens then with the engine verification? Well, we still have those times. We cannot go down them. It's true that we can be closer to the 25 minutes part than to the 80 minutes part if we use fast build. We have been trying that and we are getting a good cache hit for builds. But that only is going to help once you have built something. So we cannot avoid the first spike of first content that needs to generate the cache. At the same time, as the number of changes that we're doing per day are content changes, well, it's working quite good for us. And post-submit verifications, well, we still have them there, and it makes sense to have them there, because in pre-submit, in the end, we are testing individual change list. But it's quite common that we trigger like 6 or 5 chain list verification at the same time. And when we are testing that in pre-submit, we're testing the changes individually. But then the post-submit pipelines test all them together. So it still makes sense to have them. That means that we are not running post-submit verification per every single submit. They are executed in a time basis, so they are getting batches of individual pre-submit verification and then executing additional verification over them. And they are also important for us because there we don't have time restrictions and we can do things that take much more time and we cannot do in pre-submit verification. And for the second part, how the teams collaborate and how the challenges for our games are affecting our workflows. we're gonna start to talk about all the source changes that we have. And one of them, yeah, of course, is how do we update the engine? And the engine version that we are using is a fork from from the Hazelight version of the engine. If you are not familiar, Hazelight is a company also from Sweden that basically has a fork of the vanilla Unreal Engine, but adds NGScript as a scripting language. We are using NGScript for some logic in our game. So yeah, we are forking the Hazelight engine. Even if we work in Perforce inside the games, the engine updates happen in GitHub. And our repository has two main sources of changes. One is the branches that we create when we need to update the engine from the upstream branches. So we downstream the content, perform a verification, and then we merge inside our version of the engine. And then we also have small divergences that we need to apply here and there. And those divergences are done as feature branches in Git, and we integrate them as a normal PR. The idea about divergences is that we don't want to have them. We want to remove all of them. So from time to time, we try to upstream everything we have doing pull requests either to Hazelight or Epic. But sometimes there are some of them that will need to live a little bit more in our thing, so they are only in our repo. That green verification is not a verification as we have been talking before. That's just compiling the editor. We still don't have game content there, so we cannot verify in the way that we want doing our tests and whatever. But the other red one is the XXM verification that we have been discussing. So one thing that needs to happen is that we need to bring that version of the engine inside Perforce. And we do that using a automatic process. We have built a small tool that we call G2P4 that basically is going to first get all the changes after a PR has been merged. It's going to move them to a vendor depot. It's a depot inside Perforce already. That's a one-to-one copy of what we have in GitHub. It's going to trigger the verifications that we have been talking about. And only when that verification is successful, it's going to merge, integrate, and submit the change to Games Depot. So this is one of the ways that we're using verification here. And the other way, of course, are the two main flows that developers use on the day-to-day basis. We are also using custom tools for those flows. They are integrated in P4V. One of the workflows is something that we call submit attempt, and that's the official way of actually submitting a change inside the games. And the other one is something that we call try jobs. Try jobs are pretty important, but let's finish first with the submit attempt part. I was looking for the post submit part. Yeah, okay. So when a developer creates a chain list inside P4V, the tool is going to be executed over .cl. So basically, this is right-click over P4V and selecting the tool. The tool is going to execute the pipeline for verification, and it's going to watch how the build is doing. And when the build finishes, in case if it's successful, it's going to submit from the developer's machine. Submit attempt is not going to generate a binary by default. Submit attempt is going to wait until a post-submit pipeline is triggered, and that will generate the binary for the developer. And the try-job tool is really important because actually it's a way where the developer can create a binary of the game without actually submitting the chain list. And the way we are doing that is that the agent is getting the latest changes from the games depot. It's applying the chain list that the developer is trying to verify over. It's going to perform verification, and it's going to generate the binaries, but without doing the submit. This is really important because that means that every single developer can create a playtest on their own. So they can generate a version. They don't need to wait, for example, until we have a company-wide or project-wide playtesting session. Those tools are desktop tools, so we will see some screenshots about them later, and we will talk about small peculiarities that they have. But the other thing that it's also important for us is that when those tools are going to run a verification, we need to bear in mind that it's going to be a selective verification. We have been talking about the two types of main verification that we have, light verification for content agents and heavy verifications for engine files. But we have two projects that are using the same technologies, and we said that we have shared code between them. So this means that we have the arc radus pipelines and we have the finals pipelines. The tools are going to be clever enough to know that if your change requires only the arc radus pipeline verification, that's the verification that you're going to do. But if your file is affecting both projects, you are going to verify in the both pipeline. You are going to verify in the finals and arc radus pipelines. So it's important to have in mind that verification is selective always. We have been talking about some, but we have much more type of verification and much more of verification steps that can be triggered depending on what you modify. TryJobs looks like this. It's a really simple desktop application. And one of the features that is important is that even if we have been mentioning that the verification pipeline is picked automatically, with the TryJob you can override that decision. Usually you don't want to overwrite it to test less. You want to overwrite it to test more. I mean, I'm going to do the TryJob with the normal pipeline that you are going to pick. But if I know that I want to test this change as if this was another kind of build, I will be able to pick my verification pipeline manually. Yeah, and that's all. As we have been mentioning, it's going to create a full binary, and that full binary can be promoted to a playtest. The submit attempt, well, in fact, they are the same tool. It's just that they change the UI depending on the parameters that you are calling them. The submit attempt is the official way that developers use to submit a CL. And they have more, let's say, management features. Like, for example, you need to provide a list of reviewers. That means that your CL should have been reviewed before in a Helix Swarm review. It's going to have Jira integration. And that's important because of two things. One is because if the submit passes, it can close the Jira automatically, so you don't need to go there and lose more time changing applications. But for other workflows, some metadata or some tags are read from Jira. So it's important to know that CL or the CL that you're performing to which Jira is related to. So we do that also in this part of the tool. Submit policies. At the beginning, we were discussing that the two teams are working on files that are shared between the projects. And that raises a question. If I'm going to touch one of these files, maybe I know the status of my project, but maybe I don't know the status of the other project. Maybe I know that I don't have an important milestone, but how do I know that the other team has an important milestone or not? So submit policies are more or less like we could understand this as traffic lights in a crossroad. We can define one submit policy per project, and the tool is going to pick the more restrictive of the policies depending on the files that you are modifying. And the different policies are this one that we see listed here. Normal is no policy. I mean, you can do everything in the tool. Stability removes some features from from the tool, you are not able to perform a force submit. Release, for example, requires that the shell should be approved, and the way of doing that is because the Jira task that is related should have an expected tag that only a team in Embark can do. And log is something that I think we only use it once when we had a break that we need to study and stabilize. But besides that special case, we never use it. So this is only for special occasions. Both workflows generate a binary, although we know that try jobs do that on their own, and submit attempts require the post-submit pipelines to perform some extra job. And the way of creating a playtest is that we then have another web application tool in this case that lets us provide the additional configuration artifacts that are needed to allow server to start and the client to find the server and all the things that are needed to deploy the server and running. And the important part about this tool is that, as we were mentioning before, is that any developer can create a playtest session. That means that even if you are not submitting, you could create a try job from your CL that it's only on your machine. You are able to create a playtest to test with your team and share that using something that we are using deep linking to communicate versions to the team. So we are able to put a link in a Slack, for example, and the playtest version is going to be downloaded through this tool. This is an internal tool. It has nothing to do with an external launcher. We call it Embark Launcher, and it's the official way to receive editor updates, playtest versions, and even tools. And by tools, I mean things like Blender, for example. So everyone at Embark has this launcher. And this is the way we are distributing playtests and binaries. Before moving to the last section, there are three special problems that I think it was mentioned. One is related with testing. There is one testing challenge that involves presume verification there. The other two are, well, how we sync the content and the editor if we are doing this thing, because the editor is generated by a post-submit pipeline, but we are downloading for verification pipelines, and even developers are downloading those editors. And the other one is related with, not with a failing verification step, but with outdated data. For unit tests, I'm not going to go deep about this, but if you are interested, there's a talk from, I think it was 2 or 3 years ago by Rare about testing in Sea of Thieves. So if you are interested into testing, you should check that talk. But the point that I want to mention here is that if you are doing tests and you are doing presume verification, it's important that you have support for flaky test. Because if a test goes flaky and you are doing presume verification, you're going to start to get random failures with something that has nothing to do with the CL that the people is trying to submit. So we have flaky test support, and the idea is that as soon as we detect one of these tests, this is reported. Thanks to the flaky support thing, our verifications are not stopping. And we are doing this because we execute one test. If it fails, we try to run it again. And if it fails, we try to run it a third time. And if in the second or third attempt the test is passing, we are considering the verification green. But then we are reporting that that test is behaving in a wrong manner. I think it's important to have flaky test support if you are doing presume verification. The other thing is, yeah, we had to build a small tool It's really, really small. Its only purpose is to help in syncing the editor and the content. And this happens when we do a submit that contains engine modification at the same time that content modification. If someone syncs to the latest CL and gets that content, the editor that is needed to open the content is probably still not built because it's going to be built in the post-submit pipeline. So we need this tool to warn you that, hey, this is not, you cannot sync to latest. You need to sync to this safe CL that will ensure that you are able to open the content. And the tool itself will perform the sync. The idea is that we want to replace that with Unreal Game Sync. We think this is the option to go. We are on the way, but we still need to adapt some of the workflows to complete the transition. But if you have not looked at Unreal Game Sync, I suggest that you give a peek. And the last topic is related with content generation. This is because sometimes we had green builds, verification were okay, and then we started to do a playtest, and oh, the nav mesh was outdated. So in those cases, we understand that it's a manual process that should be done, but why don't we automate it? I mean, we have pipelines that can do things. So we have pipelines that modify, fix, and update content, and they submit on their own. In this case, we have Embark that we are using to execute fixed array directors, perform PSO caching, update the nav mesh, and even generate some loot assets for one of the games. Okay, and now fast iteration and stability build does not mean only caring about the happy path. It also means that I should care when things don't go as expected. And we are doing several things in case of failure to help developers. One of them is that we provide error extraction. I'm sure that you cannot read nothing in that log, but it's not because of the size of the font. It's also because you will need to spend time reading each line. And the idea is that whenever everything is executed in CI, we have a tool that parses all the output that is generated by CI. And if we detect some errors, they are generated as annotations in the, well, in this case, it's BuildKite, is the system that we're using. But yeah, the idea is to avoid the developer lose time looking into logs. The same tool is also used to extract warnings. And this is an important feature because the tool can override the finish status of the build. In this case, we have a build that was completely green. There was a warning, and the tool is overwriting the status of the build to failed. We are using this to pursue, to enforce a warning zero policy. At the same time, we know that there are warnings that we cannot remove because sometimes it's a warning that it's outside of our reach. And in that case, this tool also allows us the option to add exceptions. There's a file where we can add warnings, exceptions, and they are going to be ignored. Of course, it's not the ideal case, but you could use a tool like that even after, if you are not paying attention now to your warnings, and you could use the allow list to, hey, I'm going to allow everything that I have now. I'm going to not allow any more warnings than these ones, and then you start treating them. Then you start cutting that allow list until you reach your zero warnings things. Warnings hide errors, so we should not have warnings. And then alerting. Okay, let's assume that something went wrong. What do we do now? Who pays attention that that thing has failed? So the idea is that the pipeline itself can send messages to Slack. So if it's clear which is the user, the message will be directed to the exact user that triggered the submit attempt or the try job tool or the try job. And we also have special channels. It's more or less like an opt-in version of the individual verifications for specific cases. So if someone is interested in those kind of errors, they will be in the channel, so they will be aware of those kind of changes. We have alerts for much more things than just failure builds. In that case, we can see one alert done by the CI system complaining about low disk space in one agent. This is done with a different system that mixes log information and some metrics that we get from agents inside the machines. And even if they look like they are not important, in fact they are, because if that agent, for example, starts failing because it does not have enough disk space, this is going to become like a snowball. I mean, it failed, but now it's available to perform a new job. It's going to pick a new job. It's going to fail, so it's going to clean all the queues failing everywhere. Of course, this is a forced example because we have strategies so the agents can clean themselves. So, but yeah, this is a way of saying an agent is complaining about something. Maybe someone should need to look at it before this is worse. And then we finally reach the human component of the system. If things go even more wrong than this, all the verifications failed. We have two roles. They are rotating roles. This does not mean that there's one guy that is this thing. But one of them is we call the sheriff. They are notified via Slack. We have a user for that, so everyone can call sheriff at some point when they have a problem. And they focus mainly on game code and content issues. We need to have in mind that this is the first point of contact. If a problem appears, this does not mean that the guy that is the sheriff that day is the one that should solve the problem. But it's the first that has the local knowledge of where the problem is to know who to ping or how to investigate it, how to investigate the thing to continue resolving the problem. At the same time, when failures happen in the game part, we are applying a policy of reverse first and investigate later. I mean, the idea is unblock first the rest of your team and the rest of the project, and then we can see why the build went wrong. Whenever this happens, we try to extract as much information as possible, because the idea is, okay, we can solve it manually once, but this should go into an additional verification inside the tool, an additional alert somewhere. So iterating through this, the idea is that you make your automations better and your verifications cleverer. And we have another role that we call the CA Trooper. It's exactly the same than the other role, but this is focusing on build machines and infrastructure. It's quite common that both interact when something happens and it's not clear exactly what went wrong. So human net, or let's say human is the last line of defense. No? So we reached the end. Some takeaways. Spending time in individual testing and verification is preferred over breaking main. I don't think I need to explain that. If I need to verify things and I need to spend 1 extra hour, this is just 1 extra hour. But if I break the build, maybe I'm spending 1 extra hour of 100 people. So do it. Spend time verifying things on your own. We think that fast pre-submits are possible in real, and I was really happy listening at the talk yesterday that the problems that we had making those times lower are going to disappear at some point. So yeah, I think we should keep doing pre-submit verifications. And also automate as much as possible, but not only task, also information access. This means deep linking whenever possible, alerts in Slack, log parsing, warning extraction. So yeah, happy builds, everyone.